This week I had a test on circuits and I had several questions related to how can we find missing information in a circuit. So today we're going to do a little bit of looking at the series circuit and parallel circuit, trying to figure out what is the missing information, a bit like a little puzzle. So let's see what we have. So first of all, you'll notice that we are using symbols in circuits. So here when you have this symbol, it means a source. The circle with the cross is a bulb. Always remember to use a ruler when you are tracing those on your evaluations. It's always neater and cleaner. Otherwise, let's see what we can look into. So first of all, let's look at some information about circuits. So here, the first example will be about the voltage or potential difference. So first of all, when we have a series circuit, keeping in mind that the total voltage at the source is the sum of all the voltage at each of the component. And with respect to the current is the same at each component if it is in series. On top of that, you could say that when you have parallel circuits, the total voltage at the source, for example, is equal to each of the components on each of the branches of the parallel circuit. And if you think of the current here, the total current at the source is the sum of all the current in each of the branches. So this will be used for this coming video. Okay, so here's an example. We have a source, we have a bulb right here. Here we have a parallel section on our circuit, and then we go back to our source. Now, if you look at the symbol, this tiny line here, oops, is a negative sign, and here we have the positive sign. So that means that the flow of electrons will be going this way. Perfect. So how does this work? So first of all, we have to notice that here we have the voltage at the source going to the bulb, but here we have a section that is parallel. Now, what's interesting with parallel circuits, when we think of the voltage is the same for each of the branches. So here, if I have a 3 volt here and we have a parallel circuit, that means that we have 3 volts here as well. So this answers our first question. But the next question here is about the voltage at the source. Now, if I hide this portion right here and I look at this example, we have electrons giving some energy here, giving some energy there before it goes back to the source. So that means that the voltage at the source is the sum of both of these. So 6 plus 9 plus 3 is 9 volt. So let's double check what's going on with the electrons here. We have electrons here gathering 9 volt of energy, going here. All of them are dropping 6 volt. As we get to the intersection, some electrons will go down here, some other will go down here, and each of them have 3 volts. And that's what they drop here because we have the same type of bulbs. And then we go back here to go back to the source to get more energy. So here is our first example. Let's see if we can look at a second example with respect to voltage, and then we'll go from there. So give me a moment. Let's see our second circuit here. So here we have a circuit, we have the same source, but here we have 12 volt. So that's the total voltage for the electrons at the source. We have the first bulb here at 2 volt. Here we have an intersection. We have 2 different branches for parallel circuit coming back here to this bulb right here, back to the source. So here I'm looking at the missing information. So you will see that as we go through the examples, you'll see, well, it is always the same type of work, and that is true. So here, if I had just 2 pieces here, I see that I have 2 parallel branches here. So if I have 6 volt here, this automatically will be 6 volt. So we're done with this number right here. Now, if I hide this part right here, and I know that the electrons have 12 volt here, and I would drop and I will put 2 volt here, 6 volt here. How many are left before we go back to the source? So 12 minus 2, we have 10 left, minus 6, we have 4 left. And therefore, we have 4 volt here at the last bulb. So if you were to look at the journey of the electrons, we have 12 volts here for all the electrons, 2 are dropped here, so I have 10 left. All of them are going here, and they're giving 6 volt to each of the bulb here. So that means that we have 4 volt when we get to this point. And when we reach this bulb right here, we give the leftover energy to go back to the source. And that will be how we find the voltage at different portions of the circuit right here. So let's see if we can have more examples, but this time we're going to look at the current at each of these places. So let's look at this example right here. So I have a circuit similar to my first example with a source here, a bulb going to a parallel circuit before the electrons are going back to the source. Looking at the symbol here, I know that this is the negative end, so the electrons are moving this way. Now we have to keep in mind that when we are looking at current, when it is series, each components on the series segments have the same current, whereas if we have a parallel circuit, we are adding the current. So let's see what we have here. So we know that we have 6 amps going through this bulb right here. So if I am to hide this portion, there's only one path for the electron along this conductor right here. So if 6 amps are here, we have automatically 6 amp going through the source. So 6 amps being the number of electrons or number of amps going here to the second bulb. We have 6 amps. We get to this part here where the electrons can go in 2 different ways. So if we have 2 amps going here, that means that the last one would have to be 4 amps. This way. So we have 6 amps of electrons going to 6 here as well, one path. 2 are going here, that means 4 going there. We're going down, we're meeting back again before we go back to the source. An example for that would be if, let's say, you are a group of 6 friends and there's 2 possible activities to do in the evening. What will happen here is you leave the house with 6 people, you get in the car, you're 6 people. When you get to the place, 2 will do an activity, 4 will go and do another activities. Then you meet afterwards to go back to your house. So this is more or less how it works. Let's see if I can do a second example for you. So here is another example. We're looking at the current. Now we know that at the source, oh, there we go, we have 5 amps going through. But if you look, if we have the same path, the current is the same for all the components when there's only one way. So that means at this one, we have 5 amps. This one, we have 5 amps as well, because there's only one way for the electrons to go along here. Now, when we get to the intersection, we have 2 different paths. That means that if one of the parallel segment has 1 amp, all the other ones will go to the next one. And here we have 4 amps going for the last bulb. So let's see. We have 5 amps through the source going to 5 amps through this bulb right here. We have an intersection. 1 amp will go here, 4, and then we'll come back here, and with the 5 amps are here together again. Then we have 5 amps and 5 amps to the source. So this whole idea here is like a puzzle. We try to figure out what information is given and how we can answer the missing information. So let's see if I can do our last example for today. So here's my last activity. So for this activity here, I'm giving you both the current and the voltage, and I'm looking for the missing information at the source here in amp and the voltage, and in the last bulb right here. So here we have to look at the information we have to try to figure out what's missing. So here we have a mix of series and parallel circuit. So if I hide this part here, I realize that this and this, they are 2 parallel circuits. So if they are the same, so we have here a parallel circuit. That means that if we have 3 volts here, we have 3 volts as well for the next one. Let's see if I can get the blue. Perfect. So this is a given, we know that. With respect to amps here, I cannot use, it's not the same because the amps are not behaving the same thing as the voltmeter. So from here, we have the next information. So let's see. If I hide this section here, and I know that I have 2 amps here, but I have 3 amps there. Because they're only one way, we know that 3 amps going here would mean that we have 3 amps at the source as well. So that's a good thing to know, because if we have 3 amps here, 3 amps there, and when we get to this intersection, 2 amps are going down, that means for this one here, we have to have 1 amp. Like this. So that's a good thing, because now we have the number of amps everywhere in the circuit. Now what we're missing is still the voltage right here. We know that the voltage here, the potential difference is the same for both components here because they are parallel. If I hide this one here, I know that I have 2 amps, and then we have a total of 3 amps. That's okay. We have 3 volts here, but because we have a series circuit, the voltage here is the sum of the 2 voltage here. So if I have 3 volts here and I have 2 volts here, 3 plus 2 gives us 5 volts. And I have 5 volts at the source. So if we look what's happening, we have 3 amps of electrons going this way at 5 volts. At this example here, 2 amps are going down at 3 volts. And here 1 amp is going there at 3 volts. They go here, they meet, and when they cross at the bulb right here, total amp is 3 and the voltage is 2. And hence we were able to find the missing information. So if you have any clarification questions, please put them in the comments below. Otherwise, I wish you an excellent day. And if you're not quite sure what the next step is, I'm going to put here a link to another video for you to go and learn something new.